Dealing with local code enforcement often involves navigating interpretations that may seem unusual. Here are some common approaches to consider. Firstly, familiarize with the local code. Thoroughly review the specific codes and amendments in the local jurisdiction. This will help you identify any unusual requirements that may not be standard practice elsewhere. Secondly, communicate with the authority having jurisdiction, abbreviated as AHJ. Engage with the AHJ to clarify their interpretations of the code. Seek guidance on specific issues that seem unclear or deviate from standard practices. Thirdly, educate and advocate. Provide technical information and rationale to the AHJ. Explain why a particular requirement may not align with the overall intent of the National Electrical Code or generally accepted industry best practices. Fourthly, follow procedure. If a requirement is not in direct and obvious violation of the adopted code, it may be prudent to comply. Do so at least temporarily until you can obtain a formal appeal or clarification. Fifthly, document an appeal. Keep detailed records of all communications, decisions, and actions that you take. If a specific requirement is deemed unreasonable or unsupported by the code, consider filing an appeal through the appropriate channels. In one specific instance, the equipment grounding conductor splices in each box were required to be made using non-reversible connections such as crimped sleeves. A possible misinterpretation is that the rule against reversible splices in grounding electrode conductors was being misapplied to splices in boxes. To address this, firstly identify the specific code section that is believed to be misapplied. Secondly, contact the AHJ to clarify their intent and the rationale behind this requirement. Thirdly, explain why crimp sleeves are not necessary for equipment grounding conductor splices in boxes, emphasizing that these splices do not present the same safety concerns as grounding electrode conductor splices. Fourthly, if the AHJ remains firm in their stance, comply for the time being while carefully documenting the issue. Fifthly, consider filing an appeal or collaborating with industry organizations to challenge the requirement through formal channels. Here are some additional tips. 1. Stay updated on code changes and any local amendments that are implemented. 2. Network with other electricians and industry professionals in the area. Sharing experiences and insights can be valuable. 3. Seek assistance from organizations like the National Electrical Contractors Association or the International Brotherhood of Electrical Workers. These organizations can provide guidance and support. 4. Always maintain a professional and respectful demeanor when interacting with the AHJ, even when disagreements arise regarding their interpretations. Remember that the National Electrical Code, or NEC, is a comprehensive set of standards, but local jurisdictions can adopt and amend it. It is essential to understand both the NEC and any local variations. When dealing with grounding electrode conductors, the NEC has specific requirements for reversible connections. This is because the grounding electrode conductor is a critical safety component that connects the electrical system to the earth. The integrity of this connection is paramount for providing a low-impedance path for fault current to return to the source, thus facilitating the operation of overcurrent protective devices such as circuit breakers or fuses. Reversible connections, such as wire nuts, are generally not permitted for grounding electrode conductors because they may loosen over time due to corrosion, vibration, or other factors, increasing the resistance of the connection and compromising its effectiveness. However, equipment grounding conductors serve a different purpose. They provide a path for fault current to return to the source from equipment enclosures and other metallic parts. While it is essential that these conductors are properly connected, the same level of stringency regarding irreversible connections is not typically applied to equipment grounding conductor splices within boxes. Wire nuts, for example, are commonly used and generally considered acceptable for this purpose, provided they are properly sized and installed. The AHJ requirement for reversible connections on equipment grounding conductor splices may stem from a conservative interpretation of the code or a misunderstanding of the different roles of grounding electrode conductors and equipment grounding conductors. By engaging in constructive dialogue with the AHJ, you can help to clarify the intent of the code and advocate for a more practical and widely accepted approach. When preparing to communicate with the AHJ, gather all relevant documentation, including the specific code sections in question, manufacturer's specifications for the connectors you intend to use, and any relevant industry standards or best practices. Be prepared to explain the technical reasons why you believe the requirement is unnecessary or inappropriate. For example, you could explain that wire nuts are listed for use with equipment grounding conductors, that they provide a reliable and secure connection when properly installed, and that there is no evidence to suggest that they pose a significant safety risk in this application. You could also point out that requiring irreversible connections for equipment grounding conductor splices would add unnecessary cost and complexity to the installation without providing a commensurate increase in safety. If the AHJ is receptive to your arguments, they may be willing to reconsider their interpretation of the code. However, it is also possible that they will remain firm in their position. In that case, you will need to decide whether to comply with the requirement or to pursue a formal appeal. If you choose to comply, be sure to document the situation thoroughly. Keep records of all communications with the AHJ, including the date, time, and content of each conversation. Also, keep copies of any documents that you submit to the AHJ. This documentation may be helpful if you later decide to file an appeal or to challenge the requirement in some other way. If you choose to file an appeal, be sure to follow the proper procedures. Consult with an attorney or other qualified professional to ensure that you are following all applicable rules and regulations. The appeal process can be lengthy and complex, but it may be the only way to get the requirement overturned. In addition to the above, consider networking with other electricians and industry professionals in your area. Sharing experiences and insights can be invaluable. You may find that others have encountered similar situations and have developed effective strategies for dealing with them. You can also learn about local code changes and amendments before they are officially announced. Furthermore, seek assistance from organizations like the National Electrical Contractors Association or the International Brotherhood of Electrical Workers. These organizations can provide guidance and support. They may also be able to advocate on your behalf with the AHJ. Remember, it is always important to maintain a professional and respectful demeanor when interacting with the AHJ, even when disagreements arise regarding their interpretations. The AHJ is responsible for enforcing the electrical code, and they are ultimately trying to ensure the safety of the public. By working constructively with the AHJ, you can help to ensure that the electrical code is applied fairly and consistently. The National Electrical Code is updated every 3 years, so it is important to stay current with the latest changes. You can purchase a copy of the NEC from the National Fire Protection Association, or you can access it online through a subscription service. There are also numerous training courses and seminars available that can help you to stay up to date on the latest code requirements. In addition to the NEC, there may be other codes and standards that apply to electrical installations in your area. For example, there may be local building codes that address electrical safety. It is important to be familiar with all applicable codes and standards before beginning any electrical work. The authority having jurisdiction typically has the final say on electrical installations. They are responsible for interpreting and enforcing the electrical code. It is important to work closely with the AHJ to ensure that your electrical installations comply with all applicable requirements. When in doubt, it is always best to consult with the AHJ before beginning any electrical work. They can provide guidance on specific code requirements and help you to avoid costly mistakes. Electrical work is inherently dangerous, so it is important to take all necessary precautions to protect yourself and others. Always de-energize circuits before working on them, and use appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and insulated tools. If you are not comfortable performing electrical work yourself, it is best to hire a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. They can also help you to comply with all applicable codes and standards. When hiring an electrician, be sure to check their credentials and references. Also, ask for a written estimate before the work begins. The estimate should include a detailed description of the work to be performed, the materials to be used, and the total cost of the project. Electrical inspections are typically required for new electrical installations and for major renovations to existing electrical systems. The purpose of an electrical inspection is to ensure that the electrical work complies with all applicable codes and standards. An electrical inspection can help to identify potential safety hazards and to prevent electrical fires. If you are planning to have electrical work performed, be sure to contact your local building department to determine whether an electrical inspection is required. Electrical codes and standards are constantly evolving, so it is important to stay informed about the latest changes. By staying up to date on the latest requirements, you can help to ensure that your electrical installations are safe and compliant. Electrical safety is everyone's responsibility. By taking the necessary precautions and by working closely with the AHA, you can help to prevent electrical accidents and to protect yourself and others from harm. Remember to always follow the electrical code. It is there for a reason. Ignoring the code can lead to dangerous situations. Also, never take shortcuts when it comes to electrical work. Always do the job right the first time. And if you are not sure how to do something, ask for help. There are many resources available to help you learn about electrical safety. Take advantage of these resources to protect yourself and others from harm. The NEC addresses safety standards for electrical design, installation, and inspection. It covers wiring, overcurrent protection, grounding, and equipment installation. The code aims to minimize electrical hazards. It is updated every 3 years to incorporate technological advancements and address emerging safety concerns. Local jurisdictions adopt and amend the NEC based on their specific needs. These amendments can address climate conditions, population density, and infrastructure differences. Electricians must be aware of both the NEC and local amendments. The authority having jurisdiction is responsible for enforcing electrical codes. This is usually a local government agency or inspector. They review plans, conduct inspections, and ensure compliance. Clear communication with the AHA is essential for project approval. Understanding the AHA interpretation of the code prevents delays. Seeking clarification on ambiguous requirements is crucial. Sometimes the AHA may have specific interpretations of the code. These interpretations might differ from standard industry practices. Addressing these differences requires open communication. Provide technical justifications for alternative approaches. If the AHA interpretation seems unreasonable, document the concerns. If necessary, appeal the decision through appropriate channels. Equipment grounding conductors and grounding electrode conductors serve different purposes. Equipment grounding conductors connect metallic parts to the grounding system. Grounding electrode conductors connect the grounding system to the earth. The NEC has specific requirements for both. For example, NEC section 250.64. C addresses the continuity of grounding electrode conductors. Section 250.118 lists acceptable types of equipment grounding conductors. Understanding the differences between these conductors is critical for safe installations. Local amendments may add further requirements. Always consult local codes and AHA. When dealing with code enforcement, maintain a professional demeanor. Even if you disagree, respectful communication is key. Present your arguments calmly and logically. Avoid being confrontational or argumentative. Building a positive relationship with the AHA can ease future interactions. Document all communication with the AHA. Keep records of emails, phone calls, and meetings. This documentation can be helpful if disputes arise. It can also be useful for future reference. Networking with other electricians can provide valuable insights. Sharing experiences and challenges can help you navigate code enforcement. Local electrical associations often host meetings and training sessions. These events are great opportunities to learn and connect with peers. Staying informed about code changes and industry trends is crucial. Attend workshops, seminars, and online courses. Read trade publications and follow industry blogs. The electrical field is constantly evolving. Continuous learning is essential for staying ahead. Consider joining professional organizations like NECA or IBRU. These organizations offer resources, training, and advocacy. They can also provide support when dealing with code enforcement issues. The NEC provides tables for conductor ampacity. For example, Table 310.15. B16 provides ampacity ratings for conductors based on insulation type and temperature rating. Understanding these tables is essential for proper conductor sizing. Local amendments may modify these ampacity ratings. Always consult local codes. Overcurrent protection is critical for preventing electrical fires. Circuit breakers and fuses protect conductors from overload and short circuits. The NEC specifies requirements for overcurrent protection. For example, Section 240.4. B addresses the protection of conductors. Local amendments may add further requirements. Always consult local codes and the AHJ. Grounding is essential for safety. It provides a low impedance path for fault current to return to the source. The NEC specifies requirements for grounding. For example, Section 250.4. A5 addresses the grounding of electrical systems. Local amendments may add further requirements. Always consult local codes and the AHJ. Bonding is also crucial for safety. It connects metallic parts to create an electrically safe path. The NEC specifies requirements for bonding. For example, Section 250.92. B addresses bonding at service equipment. Local amendments may add further requirements. Always consult local codes and the AHJ. Wiring methods must comply with the NEC. The NEC specifies requirements for various wiring methods. For example, Chapter 3 covers wiring methods and materials. Local amendments may restrict certain wiring methods. Always consult local codes and the AHJ. Equipment installation must comply with the NEC. The NEC specifies requirements for installing electrical equipment. For example, Article 400 addresses flexible cords and cables. Local amendments may add further requirements. Always consult local codes and the AHJ. Electrical inspections are conducted by qualified inspectors. They verify compliance with the NEC and local codes. Prepare for inspections by reviewing your work and documentation. Address any deficiencies promptly. Failing an inspection can delay project completion. The AHJ has the final say on electrical installations. Respect their authority and follow their instructions. If you disagree, document your concerns and appeal if necessary. Building a positive relationship with the AHJ can benefit you in the long run. When faced with unusual code enforcement, remain calm and professional. Understand the rationale behind the requirement. Communicate with the AHJ to seek clarification. Document your concerns and appeal if necessary. Collaborate with other electricians and industry professionals. Stay informed about code changes and industry trends. By following these steps, you can navigate code enforcement effectively. Remember, electrical safety is paramount. Always prioritize safety over cost or convenience. The NEC and local codes are designed to protect people and property. By complying with these codes, you can help ensure a safe and reliable electrical system. When installing electrical equipment, follow manufacturer's instructions. Proper installation is crucial for safe operation. If you are unsure about any aspect of the installation, consult with a qualified electrician. Electrical work should only be performed by qualified individuals. And trained individuals can make mistakes that could lead to serious injury or death. If you are not qualified to perform electrical work, hire a licensed electrician. Working with electricity can be dangerous. Always take precautions to protect yourself from shock and electrocution. Wear appropriate personal protective equipment, such as gloves and safety glasses. De-energize circuits before working on them. If you are not sure how to de-energize a circuit, consult with a qualified electrician. Never work on electrical equipment while it is wet. Water is a good conductor of electricity. Contact with water can increase the risk of shock and electrocution. If you must work on electrical equipment in a wet environment, take extra precautions to protect yourself. Use ground fault circuit interrupters, or GFCIs, to protect yourself from shock. GFCIs are designed to trip when they detect a ground fault. A ground fault occurs when electricity flows through an unintended path to ground. GFCIs can prevent serious injury or death. Inspect electrical equipment regularly for damage. Damaged equipment can be hazardous. Replace damaged equipment immediately. Never use damaged electrical equipment. Keep electrical equipment clean and dry. Dust and moisture can cause electrical equipment to malfunction. Clean electrical equipment regularly. Store electrical equipment in a dry place. Avoid overloading electrical circuits. Overloading circuits can cause them to overheat and start a fire. Use the correct size circuit breaker or fuse for each circuit. If you are not sure what size circuit breaker or fuse to use, consult with a qualified electrician. Avoid using extension cords whenever possible. Extension cords can be a fire hazard. If you must use an extension cord, use a heavy-duty extension cord that is rated for the intended use. Never run extension cords under rugs or furniture. This can trap heat and cause a fire. Unplug electrical appliances when they are not in use. This can save energy and reduce the risk of fire. Teach children about electrical safety. Children should be taught not to play with electrical outlets or appliances. They should also be taught what to do if they see a down power line. Electrical safety is everyone's responsibility. By following these tips, you can help prevent electrical accidents and protect yourself and others from harm.